In this video, you will learn how to find the real values of y in this nice expression that is given to us. Don't forget to give this video a thumbs up. Also, subscribe to my channel for more simplified mathematics content. Remember, we are to find the real values of y. Now, to find the real value of y, we want you to note these two things. They are going to be beneficial as we go ahead in solving this question. Remember that 12 can be equal to 4 multiplied by 3, right? And then we can have 8 to be equal to 4 multiplied by 2. As for 80, we're going to work on 80 as time goes on. So let's get started. To solve this expression, let's take this to be equal to y to the power of 4, right? Remember, multiply by 3 according to the law of indices, plus we'll have y to the power of 4 multiplied by 2, and this will be equal to 80. Great. So we are having this to be equal to this. Now, if you look at that expression very well, you're going to see that we'll have a unique value. Now, let's subtract 80 from both sides. We'll have our y to the power of 4 all to the power of 3 plus y to the power of 4 all to the power of 2, and this will be minus 80. And this will be equal to 80 minus 80 is going to give us 0. So that expression is taken. Now from this expression, let us let the value of y to the power of 4 to be equal to x. So if we let the value of y to be equal to y to the power of 4 to be equal to x, that means simply wherever we see y to the power of 4, replace it with 4yx, and this will be x to the power of 3 plus x to the power of 2 minus 80, and this will be equal to 0. Now let's solve this equation using the polynomial method of solving equations. Polynomial equation. Remember, this is a polynomial equation. Now the first thing we are going to look for the simplest value. Will substitute for the value of x such that the left hand side will be equal to 0, and that will tell us that that is simply a factor of that polynomial equation. Then we can now find the other two factors. Now if we take our x to be equal to 2, if we take our x to be equal to 2, what are we going to arrive at? We're going to arrive at 2 to the power of 3 plus 2 to the power of 2 minus 80. Will this give us 0? Now let's see, 2 to the power of 3 is equal to 8. 8 plus 4 minus 80 absolutely is not equal to 0. So let's look for a larger value. Let's assume, if we assume 3 will not go, because 3 to the power of 3 is equal to 27. And 3 to the power of 3 is equal to 9. 9 plus 27 will not be able to subtract this to give us 0. Now let's assume that our value for x is equal to 4. Now if we assume our value for x is equal to 4, we'll have 4 to the power of 3 plus 4 to the power of 3 minus 80. Will it give us 0? Now let's try. 4 to the power of 3 is 64, right? Plus 4 to the power of 2, this is power of 2, sorry. That 4 to the power of 2 will give us 16 minus 80, and this is going to give us absolutely 0, because 64 plus 16 is equal to 80. So 80 minus 80 is equal to 0. So you see, x equal to 4, which presumably gives us x minus 4, is a factor to that polynomial equation. So the whole job we have now is to find the other factor. Remember, we have x minus 4 to be equal to 0 as a as a factor. So let's look for the other two factors. Now, to look for the other two factors, we are still going to consider these two things: 4 to the power of 3 plus 4 to the power of 2. Now, let's look at those two expressions. If we look at those two expressions and consider the initial expression we are given, we are told that we have x to the power of 3, right, plus x to the power of 2, right, minus 80, and we said it's equal to 0. Now remember that if we have minus 80, our minus 80 can still be equal to 64 plus 16. And remember that our 64 plus 16 is simply equal to 4 to the power of 3 plus 4 to the power of 2. Now we're going to substitute that to replace what? 80. Because our negative 80 is equal to, our negative 80 is going to give us this time around a negative, is going to give us a negative 64 minus a negative 16. So that will give us what? Negative 80. So let's apply that to that expression. So we'll have x to the power of 3 plus x to the power of 2 minus 64 minus 16, and this will be equal to 0. Now recall that 64 and 16 both are expressions that can be replaced by 4 to the power of 3 minus 4 to the power of 2, and this will be equal to 0. While we'll have x to the power of 3 plus x to the power of 2. Great. So if we simplify this, what we are going to have is just to collect the both like terms. So we'll have our x to the power of 3 minus 4 to the power of 3 plus x to the power of 2 minus 4 to the power of 2 equal to 0. Now, if we solve this solution, this equation, we should be able to get the other quadratic equation that will give us a unique solution. Now, remember that from this algebraic expression, a to the power of 3 minus b to the power of 3 can be equal to a minus b, right? And then we'll have a square plus ab, and then plus b what? Square, right? And we'll have a square minus b square. This can be equal to a plus b, right? And then we'll have a minus b. Now from that expression, a is absolutely s, and our b is definitely what? 4. So let's substitute that into that expression. If we do that, for the first one, x to the power of 3 minus 4 to the power of 3, we are going to have x minus 4, right? And then we'll have the other expression, x squared plus 4 times x plus 4 square, and this will be plus what? 1 multiplied by x plus 4, and then we'll have x minus 4, and this will be equal to 0. Great. So having seen that expression, we are going to simplify. Now, if we want to simplify, we want to divide all these whole place because x minus 4 is common. So let's bring out x minus 4. So we divide this whole place by x minus 4 and divide this whole place by x minus 4. So if we do that, we are going to have this expression to remain x squared plus 4x plus 16, right? 4 squared is equal to 16, and if we divide here, we're going to have plus x plus 4 remaining on this side, and this whole thing will be equal to 0. So this has brought us to what we call the zero product law. From the zero product law, we'll have our first case, x minus 4 to be equal to 0. And then we'll have our second case to be x squared plus x plus 4x plus x will give us plus 5x plus 16 plus 4 will give us plus 20, and this will be equal to 0. Voila! Remember, we've already gotten this solution, the first place, as the first solution, where our x is equal to what? 4. So we've already gotten this. The next thing is to find the solution to this quadratic equation. Now, to find the solution to this quadratic equation, remember, we are asked to find the real values of x. So we are going to first find the discriminant of these values to see if they are definitely going to give us a real solution or an imaginary solution. So we have 4ac. So remember, from that expression, a is equal to 1, b is equal to 5, and c is equal to 20. We don't want to waste time in solving it, but let's find out if it will give us a real solution or an imaginary solution. So the discriminant will be equal to 5 what? 5 squared minus 4 multiplied by 1 multiplied by 20. So this is going to give us 25 minus 4 times 2 is what? 80. So the discriminant will give us what? The discriminant will be equal to 25 minus 80 will give us a negative what? 55. So what does that tell us? That negative 55 is what? Is less than what? Is less than 0. It's not equal to 0, rather it is less than what? It is less than 0. So since it's less than 0, that shows that the solution that will come out from this quadratic solution will definitely be what? Imaginary solution, and they can never be real solution. You can check that out, solve it out, and then see if that solution will definitely give you imaginary solutions. Then if you have that, we'll come to see that the only real solutions to this algebraic expression is x equal to 4. Now let's take our way back. Remember, we made the value of y to the power of 4 to be equal to x, and we are asked to find the real values of y. So to find the real values of y, remember, we've been given that y to the power of 4 is equal to x, and we have our x to be equal to 4. So y to the power of 4 is equal to 4. So we'll take the fourth root of both sides. If we take the fourth root of both sides, we'll have our y to the power of 4 equal to the fourth root of what? Of 4. Now if this clears this, we'll have our y to be equal to 4 to the power of 1 divided by 4. And this will be equal to 2 to the power of 2 multiplied by 1 divided by 4. What would that give us? That will give us the value of our y to be equal to 2 to the power of 1 divided by 2. Great. So that is the solution, the only real solution to that exponential equation that is given to us up there. Now we are going to check if this solution is absolutely right. We are going to check by inserting the value of x or y equal to 2 to the power of half in that expression. Will it give us 80? Now let's check. Y to the power of 12, y to the power of 12 plus y to the power of 8. Is it going to give us 80? Now y to the power of 12, that will give us 2 to the power of 1 divided by 2 multiplied by 12, right? And this will be plus 2 to the power of 1 divided by 2 multiplied by 8. And what would that give us? Remember, the exponent will multiply, and then we'll have 2 to the power of 1 divided by 2 multiplied by 12 plus 2 to the power of 1 divided by 2 multiplied by 8. While this clears this to give you 4, this will clear this to give us 6. So we'll have that expression to now become what? 2 to the power of 6 plus 2 to the power of 4. 2 to the power of 6 is equal to 64, right? Plus 2 to the power of 4 is equal to 16. This plus this is equal to 80. So it did give us 80. So that tells us that the solution y equal to 2 to the power of 1 divided by 2, or the square root of 2 is the solution to that exponential equation that is given to us up there. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up. Also, share it with friends and colleagues. Remember to also subscribe to my channel for more simplified mathematics content. Thanks so much for watching, and bye bye for now.